Hey, this is Mr. A, and I was so interested in the work that you guys were doing at home by rolling your marble down a ruler. I decided to see what kind of results that I could get with some of the equipment that we have at school. And so this is a marble run that I have, and I have some laboratory measurement equipment that I'm using with a laptop and some photo gates right here. And so what happens is there's a little sensor on this gate and a sensor on this gate. And when the marble rolls down the track, it trips this sensor, it starts a timer, and then the timer stops when it hits this gate right here. So if I know the distance between the gates and the time it took to get from one gate to the next, then I know the speed of the marble. Another thing that I've done is I've measured a distance for height on the ramp here. So I don't know, maybe this is like a 20 or a 30-degree ramp. That's not important. What's important to our lab is how high it is above the flat part of the marble run here. So I've got it measured off at 1 centimeter above, 2, 3, 4, 5 centimeter above, just like you did at home. And with this data acquisition software and equipment, I can get some very accurate measurements. So if I go to the 5 centimeter mark and I put the marble right here and then I let it go, and it takes one measurement, and I can very quickly make several measurements in a row for this one height. So there was 5 runs, and I could average those 5 runs together. And I get a printout here, and I get some pretty consistent readings. So I came into work, and I did this, and I got measurements for 5, 4, 3, 2, 1 centimeters. And I am going to compare that with some theoretical values that I should get. And the idea is that you will have something to compare your data with that should be fairly accurate. Then that way we can calculate some experimental error by calculating the percent difference between what you got and what I got and the theoretical value. So that'll make a very nice write-up, very nice lab report.